your hair like in braids. Oh my god. I'm tired, guys. Working late, it's not mine. All right. We are going to... Is anyone else going to dress up as a math elite? He really wants to spend it. Ooh, what day is it? I won't get him in time. He really wants suspenders. All right, let's do this so Resendez can sit and stare because I'm tired. Don't forget if you want a tie-dye, come Monday.
On what,
Monday. Which part? Linear? Mm-hmm. All right, so what are the characteristics of linear functions? All right, linear function. A linear function forms a line. You're used to y equals mx plus b. But we talked about functions, so we also know we can rewrite it as f of x. Very good. F of x equals mx plus b. Remember that M identifies your what? Your slope. That's what you did yesterday. And B identifies your y-intercept. We write y-intercept as an ordered pair. It's on the y-axis, so it's always a 0 first, because x is 0, comma b. So whatever our b is, we'll go there. This is the point where the line crosses the y-axis. But all of this should be review, yes? Okay. So it's just like a refresher. Good? All right, let's talk about what we really didn't talk about yesterday, because yesterday we didn't talk about a line. We just talked about slope of the line, but we didn't show the graph at all. So there are 4 types of slope. All right, ready to identify your 4 types of slope? What kind of slope is that? Positive. How do you know it's positive? Because it's going up. So if we have positive, the opposite of positive is? Negative slope. What other kind of slope do you have? It's the kind that goes straight across. They're all linear. It's your 0 slope. 0 slope. It's horizontal because you think of the sun setting, right? You think of the beach. When you see that sunset, there's always that like line of the horizon. Your sun is that big 0 slope. And then you have this one, which is what? What? It's your undefined slope. So remember, for you to get a zero slope, where does zero have to be, on the top or the bottom? Top. Because that's what? Okay. For zero, the undefined slope, where does zero have to be? On the bottom, because that's a no. All right. We good? Let's go to the next part. Let's talk about x-intercept. X-intercept is the point where the function crosses the x-axis. The point where the function crosses the x-axis. Since it's on the x-axis, you have x comma 0. X comma 0. Which means your y is equal to 0 every single time. We could also solve it if we really wanted to. Most of the time it's just by looking at a picture. But we could solve it. We talked about y-intercept just a little bit, but let's talk about it again. It's also the point where the function crosses the y-axis, sorry. So in this one, if you have x comma 0, this one's going to be what? What's 0? 0 comma? Can y and x have the same spot? 0 comma y. So now x is 0. It's always x comma y. Okay? Let's talk about end behavior. Let's talk about end behavior. End behavior is the direction each arrow is pointing left to right. Left to right. I just need a couple too small little graphs. Squeeze it in there. Okay? So mainly like this. If we're looking at this graph right here, this function, it is a positive slope. But which way is this arrow pointing? Down. Which way is this one pointing? So this is down and up. If I look at this one, which way is this one pointing? Up, and this is pointing. So it's up and down. let's talk about another word. We have another word called domain. Has anyone heard the word domain? Yeah? It's your good, it's your input. So now this one's going to say, since we're talking input, we're talking about a line. It's all of the x values that are true of the function. All of the x values that are true of the function. So if we're talking domain, we also need to talk about range. And if domain is all of the x values, range is all of the what? Very good, the y values that are true of the function. We're going to talk about this in a second. Ready? All right. So listen, I want you to watch. It says all of the x values, all of them. So as this line keeps growing, right? So let's go this way. If the line's going this way, right, because that's what the arrow means, correct? Your x values are also growing at the same time. Do you understand? Is it ever going to stop? No. So what's the smallest number that's out there? Smallest. Negative infinity. Negative infinity. You can never touch it, right? You never ever can get to negative infinity, but it's the smallest thing out there. So it's going to go from all the way from negative infinity. Does that make sense? Which is really, really far because it never ends. Now this one, on the other hand, is going this way. So this one's going all the way in what direction? Positive direction. So that goes to positive infinity. Okay? So my domain, and this is how you write it, is parentheses, negative infinity to positive infinity. Now I don't need to write the plus for infinity, you can, but I always, when you say it, you have to say positive. Do you understand? So negative infinity to positive infinity. And if you don't know what that sign is, that is the infinity. That's why Buzz Lightyear says to infinity and beyond. Okay? Now let's think about this way. Your range, your y values, right? So we're talking y values now. As my graph is growing this way, is this also growing? Is it ever stopping? So that also can go to the smallest number out there, which is negative infinity. And if it's going in the positive direction, that means it's going to go to positive what? Infinity. So my range is negative infinity to positive infinity. Now, it's always from least to greatest, okay? So I never write infinity to negative. That doesn't make sense. It's always least to greatest. So it's always negative infinity to positive infinity. Now notice, I color-coded on purpose. The green is my range, which means all of the y values. Has nothing to do with an ordered pair. Do you understand that? That is not an ordered pair. It's called an interval. So it's not an ordered pair because I'm only talking y values. Here, I'm only talking x values. So it's still not an ordered pair. We write it like that, but this is called an interval. And I'm telling you this now because you're going to get to the lovely IM2. hopefully next year. And all you will do are these things called intervals. And it'll start to look like this. Okay? It's so pretty. That's an easy one. That's more fun. That's a little bit better. See? So you start to see these intervals. You see there's domain, there's range. They always go together. Do you understand? So it's called an interval. It's only x's or there's only y's. Domain is x's and range is y's. Got it? Ready for the examples. Let's cut them out. That's what these are for. I just gave you words. I haven't given you examples. So you use another page. Yep. Someone needs to let that person in that barely made it before the 8 o'clock. Thank you. All right, you ready? She's bragging she got to sleep in an extra full hour.
She's pregnant?
Well, that too. But she's
pregnant?
Yeah.
Why is she pregnant?
But she's bragging.
Oh, that's nice.
I got to sleep in an extra full hour. Why is she pregnant? Because she's pregnant. Don't mind Sierra. She's dying a little bit inside. It's not my fault.
That's going just fine, too. What'd you say? Is why? What is it?
It's early bedtime. That's all that means. I dropped my water bottle outside. It was a hot mess.
It was like 4 a.m.
Why are you up?
Why are you awake?
Oh, I just woke up early. I couldn't fall back to sleep.
So you got all
I went
those.
back to sleep. I did like stay up.
Thanks. See you later. Welcome. Okay. We worked all night, so we're a little tired. All right, ready? Why? Right, I'm going to start. You can watch so you understand what is happening. X-intercept means we're on the x-axis. So if I go along the x-axis, I'm going to find the point where it's on the graph. It is located right there. So what is that point as an ordered pair? -1, comma? 0. Very good. So there's my x-intercept. I'm going to try to switch colors so you can see the difference when I'm doing this problem, okay? Y-intercept means I'm going to go up and down the what axis? The y-axis. And I'm going to try to find where it hits the y-axis, and it's located right there. And what is that ordered pair? 0, -2 is correct. Very good. Now this graph is ugly because it doesn't have arrows, but it should. And what's your end behavior? What's your end behavior? We just went over that. Which way the arrow is pointing? Up and down. Now, domain is your x value. So remember, as my graph is getting bigger, where is it going to? What, infinity? What kind? -infinity. Then it's going to where? Positive infinity. Doesn't matter that it's going this way. It's still going out like that, okay? Does that make sense? So even though it's still pointed down, it doesn't matter because it's still growing that way, okay? So if you want to write -infinity here and positive infinity here so you can remember that, that's fine. It's up to you. Do you think it's always going to be that? Yeah, it is. Even in IM2, domain's always -infinity, positive infinity. It's your range, that's different. Okay, range. Y values. As it's going this way, what's happening? Is it both ways? Is it going both ways? Yep, so it's going from -infinity to what? Positive infinity. Is my range always going to be that for a line? Yeah, for a line it is. Because there's nothing fancy about this line, right? It literally just keeps going in both directions. It's not until I start to graph exponentials where it changes. Or when I start to graph something in IM2 where I have a parabola or an absolute value, then it changes. But for now, because it looks different. Right now, the line just keeps going both directions on and on and on. So it's just -infinity, positive infinity every single time. Got it? Okay, now slope. I don't want you to tell me the slope from here. That's easy. What I want you to do is I want you to look here and see how I labeled the 2 points? You see how they're labeled already? We're going to use those 2 points. Okay? Because I need to teach it from a graph. In order to teach it from a graph, I need to have 2 points on the line. Well, it's easy to use these 2 points because I've already marked them, correct? So when you label for slope, it's rise over run, right? We always read from left to right. So it's rise, remember it's up and down and side to the right, correct? So this is slope. So watch. I'm going to take from this point here, and I'm going to get to this point here. So I'm going to rise first, which really means I'm going down. How many did I go down? I went down 2, but it's negative because I went down. And then I go across how many? 1. So my slope is -2 over 1, right? You can leave it as -2 or you can leave it as that. Either way is okay. But I want to see you drawing these little triangles. Make sense? So if I find the 2 points, then it's really easy. Then I can just take those 2 points and figure it out. If there are no 2 pretty points, I'll show you how to find another point. So take the second example and put it in. Ready? You should have it. Okay, what's your x-intercept? What is it? How did you get 2?
Like 1.1.
1.1, 1.2, not 1.5 because it's less than that. Comma what?
0.
Very good. You have 1.1, 1.2, 1 point something, that's fine. Okay, y-intercept.
6, 0.
You have it backwards.
Oh,
So have it say the other way.
0 over -6.
0 comma -6. 0 comma -6. And behavior is what? Down, up. Domain is what? Negative infinity, positive infinity. What's your range? Negative infinity to positive infinity. Okay, slope. I don't want to use those 2 points because they're not pretty. Correct? I will use this point, though. This point's pretty. That one, not so much. But I can find another one. You ready? Pay close attention. If I'm walking along the line, I want to find where it intersects in the corner, and it's right, ooh, look at it, right there. You see it? See how that's a nice, pretty corner? Okay. Now I can count my slope. Am I going up or down? Up. How many is that up? How many is that up? 5. And to the right? 1. Positive. Should it match this? Well, it should. But I want to see the picture. Got it? Okay. Last one. Let's do this. Yeah. For this? I didn't. I went up and then over. No. No. Because then you get negatives. You always rise and run. You always go from left to right. So that's why I went from here and right. And the other one, I came down, right. It's always up or down to the right. Up or down to the right. Because up will determine positive, down determines negative, and it's always right. Okay? There's a reason why for when I graph, which is Monday. Let's go. You need to do 3 by yourself. Some of you waited for me to do 2. I don't know why. At least attempt it. In behavior, you can go ahead and call it EB. That's perfectly fine. Domain, you can just call it capital D like that. Range is capital R. And then F is slope. When you have your answer, I want you to check with someone next to you. See if you have the same thing. It should be done, yeah? Did you check with anybody? Some of you are still waiting for me to write it down. Ready? Here we go. X-intercept is what? Negative 3.5 comma?
0.
That looks good. Something similar to that? Yeah? As long as you're less than what?
4.
Less than 4, but bigger than the negative 3, like somewhere in between the two, yeah? Okay. Actually, I should say greater than 4 and less than 3. Negative 3, but it's okay. Y-intercept?
0,
0, 0,7, yes. And behavior? Down and up. Domain? Good. Range? Very good. Slope?
7 over 2.
Here, let's see. There's a point here, and there's a point here. Yeah? Or I could have used this point here, and then ran to this point here. Use what? The 6? This one?
Yeah.
And then you should have used this one. Or it could be any of those, as long as it's hitting in the corner. So either way, let's just pretend. I'm going to pretend I use this one, okay? So let's pretend I use this one and this one so I can show you what to do. So if I go up, that's 1, 2, 3, 4, right? And I ran over how many? 2. So I could say my slope is 4 over 2, but I can reduce that, bless you, to be what? Bless you. 2 over 1. Do you understand? So even if I pick a different one, that maybe I just didn't see this one, maybe I picked this one instead, or I picked even this one, as long as I reduce it, I'm okay. Got it? All right, I'm done. Finally.